Welcome to the third part of VCAA Specialist Math 2022 exam papers. In this video, we will present exam paper 1, questions 8 to 10. In question 8, many students were able to use an appropriate acceleration formula to find the velocity in terms of displacement x. In question 9, some students attempted to manipulate the integrand using trigonometric identities prior to integration, often with little success. As for question 10 part A, many students correctly identified the vertical asymptotes, turning point, and endpoints. Occasionally, a horizontal asymptote was implied. Some graphs were drawn incorrectly, showing the wrong shape or failing to be symmetric around the vertical axis. In part B, most students wrote down a correct integral with the volume of revolution. When it came to determine the value of tangent of pi over 12, some students had difficulty solving the quadratic equation arising from the double angle formula.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Specialist Math exam paper series. In this video, we will present questions from 8 to 10 of Exam 1 2022 paper. Question 8 states that a body moves in a straight line so that when its displacement from a fixed origin O is x meters, its acceleration A is negative 4x meters per second squared. The body accelerates from rest and its velocity v is equal to negative 2 meters per second as it passes through the origin O. The body then comes to rest again. The question here is to find the velocity v in terms of x for this interval. According to the definition of acceleration, A equals dv by dt, which can be written to dv by dx multiplies dx by dt, which equals v multiplies dv by dx. Hence, v multiplies dv by dx equals negative 4x, which gives the integral of v with respect to v equals negative 4 multiplies the integral of x with respect to x. After integrating on both sides of the equation, we have v squared over 2 equals negative 2x squared plus c over 2, which gives v squared equals c minus 4x squared. Here c is an arbitrary constant. So v equals plus or minus square root of the result of c minus 4x squared. Since v of 0 equals negative 2 meters per second, when the body passes through the origin O, negative square root of the result of c minus 4x squared equals negative 2, which gives c equals 4. Hence, v of x equals negative 2 multiplies square root of the result of 1 minus x squared. Question 9 is to find the rule of the function f of x, given that its derivative function f prime of x equals cosine 2x over the cubic of sine 2x, and f of pi over 8 equals 3 over 4. Since f prime of x equals cosine 2x over the cubic of sine 2x, f of x can be written to the integral of cosine 2x over the cubic of sine 2x with respect to x. Hence, f of x equals 1 over 2 times the integral of cosine 2x over the cubic of sine 2x with respect to 2x, which equals 1 over 2 times the integral of 1 over the cubic of sine 2x with respect to sine 2x, which equals the negative reciprocal of 4 times the square of sine 2x plus c. Since f of pi over 8 equals 3 over 4, negative reciprocal of 4 times the square of sine 2x plus c equals 3 over 4, which gives c equals 5 over 4. Hence, f of x equals 5 over 4 minus the reciprocal of 4 times the square of sine 2x. Question 10 shows a function f of x equals sec of 4x, and based on that, there are two parts in question 10. Part A is to sketch the graph of f of x for x is in the closed interval from negative pi over 4 to pi over 4 on the set of axes shown below. The requirement is to label asymptotes with their equations and turning points, as well as the endpoints with their coordinates. In part B, the graph of y equals f of x for x is in the closed interval from negative pi over 24 to pi over 48 is rotated about the x-axis to form a solid of revolution. The question here is to find the volume of this solid and give your answer in the form of a minus square root of b, or in parentheses times pi over c, where a, b, and c are real numbers. Now let's start to sketch the function which is required in part A. Since the function f of x equals sec of 4x, we know the period of this function is pi over 2. And within the given interval, the equations of two asymptotes are x equals plus or minus pi over 8. Obviously, the turning point is located at 0, 1, and both endpoints are at negative pi over 4, negative 1, and pi over 4, negative 1, respectively, as shown in the diagram. Since part B is to find the volume of the solid, its volume V can be written to the integral from negative pi over 24 to pi over 48 of pi over the square of cosine of 4x with respect to x, which equals pi over 4 times the integral from negative pi over 24 to pi over 48 of 1 over the square of cosine 4x with respect to 4x, which equals pi over 4 times tangent of 4x, valued from negative pi over 4 to pi over 48, which equals pi over 4 times the sum of tangent of pi over 12 and tangent of pi over 6. Up to this stage, we know the exact value of tangent pi over 6, but don't know the exact value of tangent pi over 12. However, we may find the exact value of tangent pi over 12 by applying the tangent function double angle formula. Since tangent pi over 6 equals 2 times tangent pi over 12 over the result of 1 minus the square of tangent of pi over 12, which equals 1 over square root of 3. We have the equation, the square of tangent pi over 12 plus 2 square root 3 times tangent of pi over 12 minus 1 equals 0. Since we have the quadratic form like tangent equation, we may apply the technique of solving quadratic equations here. First, we need to check its discriminant delta, which equals 2 square root 3, or in parentheses squared, minus 4 times negative 1, which equals 16. Since pi over 12 is in the first quadrant, tangent pi over 12 is greater than 0. So tangent pi over 12 equals negative 2 square root 3 plus 4, all over 2, which equals 2 minus square root 3. Hence, we come back to the previous point. The volume of the solid V equals pi over 4 times 2 minus square root 3 plus square root 3 over 3, all in parentheses, which equals pi over 4 times 2 minus 2 square root 3 over 3, which is simplified to 3 minus square root 3, or in parentheses times pi over 6.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.